Seasonic, the heart of your system.
I'm Neil Walter for Kit Guru. Asus Maximus 11 Formula is a Z390 board for Coffee Lake, or as some joker commented on my recent Leo Says About XPUs, Coffee Lake. Ho ho, I missed that comment the first time, but I got it in the end. It is a big, impressive board with a whole load of ROGness about it, and it's quite expensive. The price is typically £390. At the moment you can find it discounted to £359 at one e-tailer in the UK. You can also find it on sale for £425, which is an awful lot of money for an ATX board that supports a desktop processor that typically sells for around about the £500 mark. It doesn't come with a whole load of accessories. You get a 2-card SLI bridge, just the one of those. You don't get like a variety of spacings, USB cable, a number of SATA type cables, and also some temperature probes, which is typical ROG kind of stuff. And you get Wi-Fi antennae for the 802.11ac Wi-Fi, which I guess these days we're supposed to call Wi-Fi 5 if the new thing's Wi-Fi 6. And that's the stand for the antennae. And that's on those little plug things that goes to the front headers that you can connect your case to make it all nice and easy. Asus has clearly spent one large chunk of money on the VRM cooling system, which is by EKWB, the Slovenian water cooling people, called Cross-Chill EK3 VRM Hybrid Cooling Block. This system has been used on previous boards, so the Cross-Chill EK2 was used on the ROG Maximus 9 formula, and the original Cross-Chill EK was on the ROG Maximus 8 formula, which was a Z170 board. So the principle is tried and true. The idea is it's a chunky, great big copper cooler which goes on the VRMs. It also has 2 G-quarter unions, so you can, if you choose, plumb it into a custom loop cooling system. In principle, I quite like the idea. In practice, as you'll find out in this review, I'm not so sure. Personally, I like liquid cooling my PCs. Many people use liquid cooling on their CPU. Typically, it'd be a closed loop all-in-one. I understand it. That's nice and straightforward and quite cheap to do. You actually get more advantage from liquid cooling your GPU, your graphics card. And these days you spend a lot more money on your graphics card, typically on your CPU, but that's a whole different conversation. Liquid cooling your VRMs can be quite tricky. Doing a loop going from the VRM block to the CPU and out to the VRM and off to the pump, to the radiator, whatever, it's quite difficult doing that. Using a monoblock is much neater. I recently built a system using the Gigabyte Waterforce Z390 board, which had a monoblock. It was a hugely expensive motherboard, very neat, and that looked good. My own personal PC is a first gen Threadripper that also has a monoblock which covers both the CPU and the VRMs. It means you only have to have the 2 unions on the block rather than having 4 and having to plumb them all together. However, this Maximus 11 formula, you don't have to liquid cool it. I'm going to do that during the course of this review to see what benefits it brings, but the Cross-Chill block, the Cross-Chill 3 block, can be used in air-cooled mode, so you have a choice. Therefore, it follows you don't have to use custom loop cooling on this board. You can, if you choose, use an all-in-one on the CPU, as I'm going to do. The main features of the board are this extensive armour which covers a huge proportion of the board. I'll pull it off in a second to show you underneath, but you can see obviously the PCI Express slots are exposed, the 2 main graphics slots and the junior expansion slot at the bottom of the board. Clearly if you put a card in there, you'll be likely to block any number of these connectors here, so that slot unlikely to use. That is an M.2 cover. There are 2 M.2 slots under there. Extensive I/O panel which has the shield fitted in place already, so that's all one unit. Here we have the Live Dash, which is an OLED panel we've seen on a number of ROG boards in the past. We've got a load of USB. At this end we've got the USB 3.1 Gen 1, 6 ports. There we have USB 3.1 Gen 2, 4 ports, 3 Type A's, 1 Type C. Here we have a pair of Ethernets, one 1 gigabit Intel and a 5 gigabit by Quantia. There we have the Wi-Fi antenna connection points. There we have surround sound audio. Surprised to see HDMI. The idea you're going to use this board with the integrated graphics, less it's for fault finding. Really can't see that. And then we get more ROGness. We've got the BIOS flashback button, and we've also got the clear CMOS. Across the foot of the board we have audio, a pair of RGB connectors, that's addressable, that's regular 12 volt, retry button, fan connectors. Here we have a dedicated Asus ROG node connector. I've never actually seen a node device, thinking about it. Internal USB, that's the memo K switch, which is on by default. That allows for basically extensive memory retraining if you hit a problem. A USB 3.1 header, and here we have the front panel connectors. Going up the side of the board, we've got a dedicated water flow header, which I believe is a bits power gizmo. That's a regular fan header. Laid down SATA, laid down USB 3.1, USB 3.2, 24 pin power. Those are the start and reset buttons. That's the postcode debug display right there. And obviously it supports dual channel DDR4, just as you'd expect from a Coffee Lake motherboard. Across the top of the board, both inside and outside the shielding, we've got a 12 volt RGB connector there, the second addressable there, CPU fan headers there, a high power fan header there. Here we have an 8-pin and a 4-pin for the EPS connectors. We don't need those for Coffee Lake, we really don't. We can see a load of capacitors to do the VRM, so we'll take a close look at that shortly. And here we have the EK hybrid VRM cooling system. Before I remove the armor, just an observation, the RGB surfaces here are just remarkable. They attract dust and fingerprints like it's going out of fashion. So I flip the board over and I remove the back panel, back plate, which is aluminium. Thermal pads go on the back of the VRMs. M.2 heat shield, 2 screws. Reveals dual M.2 slots, thermal pads. I've been using this position so that protective strip is already removed. And the armor is tethered with 3 cables for the RGB on the I/O there. So that is that one. The RGB over the PCH chipset, which is there. And here we have the OLED display, the digital dash, which shows CPU temp and other good things. So there's quite a lot going on there, but it is all plastic, so thermally it has no function whatsoever. And you note that when you remove it, under here we have the aluminium heatsink for the chipset. There's your Z390. So now we've just got the EK cross-chill block to remove. And that comes away like that. So thermal pads that contact the chokes and the VRMs, and also a thermal pad connecting the heatsink to the Aquantia 5 gigabit Ethernet. And there we have it, board stripped bare. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 V-core and SoC phases, except that VRM controller there is an ASP 1400 CTB, which is an Asus rebranded part, so it's possibly a rich tech. However, it is definitely not a 10-phase part. It might be either 4+2 or 6+2, so more likely the 6+2, 8 phases in total. So we've got 2 for the chipset, and that leaves us 8 for the V-core. However, these are arranged in 4 pairs. There are no doublers. It's an unusual configuration. The VRMs are Vishay Doctomas SIC 639s rated at 50 amps a piece, so we've got 400 amps of V-core VRM. Over here we've got the VRMs for the memory, 2 phases just outside of the outboard of the memory, as you'd expect, and near the 24 pins. That's all absolutely lovely. Just flip that around to give you the alternate view, and you can see that laid out like this, there's an awful lot of ROGness going on, but around the CPU socket, surprising number of filtering capacitors for those VRMs. It's an unusual setup they've got going on here. This is very ROG. Here's our test setup. Using an Intel Core i9-9900K as an engineering sample from Intel. It's the one I actually use for the launch review. It hits 5 GHz pretty much all the time, 5.1 on a really good day, and it always runs hot. We've got the Asus Maximus 11 formula. Memory, 16 GB of G.Skill TridentZ Royal DDR4 3200, which apart from the fact it's rock solid 3200 MHz memory, it's also got the really funky lighting on it. Then we've got the Fractal Design Celsius S24 all-in-one liquid cooler. It's a 240mm Ace Tech, has done sterling work in some of our reviews. Graphics card, Founders Edition RTX 2080. SSD is from Intel, it's a 1TB SSD 7, so that's an M.2 NVMe, and the power supply is a mighty Seasonic Prime Platinum 1300 watt. Initial benchmarks are run on auto settings with XMP enabled. That's 4.7 GHz all cores in this particular setup. And then of course it's time to see how well the system can stretch its legs. Let's get into overclocking. I'm running at 5 GHz all cores with XMP enabled. Don't take too much notice of this section here, which is the Asus AI, where it predicts what your processor could do, because that's basically just reflecting the settings that I've actually put in here. You will note that Asus thinks something slightly different, but never mind that too much. Those are my settings. So we've got 5 GHz all cores, we're running on XMP, this is G.Skill TridentZ Royal 3200, and I've set the cache voltage to manual rather than auto. CPU voltage 1.35, we'll come to that when we get into Windows, and then we go to Extreme Tweaker where we have all the other good stuff. So there's the XMP details. Asus multi-core environment disabled. SVID behavior is set to typical scenario. I don't really want the BIOS attempting to second guess things. AVX offset, I've only gone for 1, i.e. 100 MHz, so 5 GHz all core or 4.9. Typically you might go for 3. So many workloads these days seem to be AVX that if you go for 3, then you're losing so much speed you might just, well, frankly leave the thing on auto, in my opinion. External Digi Plus power control, so load line calibration, auto was level 2, I've gone for level 7, i.e. 1 below the top. Current capability I've set to 140%, which is the max, obviously the default being auto, just so I've got more leeway to play. CPU power duty control I've left on T-probe, i.e. temperature rather than extreme, because when all said and done we don't want the thing to go bang in a puff of smoke, do we? These boot voltages and such like down here I've left well alone, because I don't want to be locked out of the BIOS in the event the thing refuses to play nicely. And after I'd come up with the settings that I thought might work, I then went into Tool, down to User Profile, and I saved the profile there. It's actually this number 2 that I'm using. Number 3 here might be of some interest. That's what I went to after I'd used this profile, where I got a bit more serious with attempting to move on with the VRM speeds. Here you'll see we can move the frequency from 300 kilohertz, which is the default. If we go plus, we go to 350, plus again 400, plus 450. So we're going quite big chunks, 500. And we can keep on going up to 800. I tried 500, spoiler alert, did not work. And we'll come out, oh, and the other thing is within monitor. So there we've got what the various fans are doing and such. Like if we go into Q fan configuration, we can configure the fans to the nth degree. Like the fan control, it's good. Here we are in Windows, running at a nominal 5 gigahertz all cores. Just pull this down so we can see CPU voltage, which is here. Okay, 1.35. We start Blender going, which is an AVX workload. And look, vCore 1296. So it's basically dropped 50 millivolts from 1.35 to 1.30. And that's holding rock steady. Because it's an AVX workload, we're talking 4.9 gigahertz all cores rather than 5. And if we go down to CPU temperature there, 85 Celsius. VRMs at the moment, 42. It obviously takes a fair while for the VRMs to heat up. In time they will. Numbers are CPU under load at 4.7 gigahertz all cores with 70 odd Celsius, 5.0 gigahertz or 4.9 AVX is around 90, i.e. we're at the upper limits. VRM temps, 4.7 out of fan was low 50s. 5.0 gigahertz, give it time, the VRM temp will go to the high 60s without a fan. With the fan that I've got here, this 120mm noise blocker, the temperature will be maintained for the VRMs at low 50s. On auto settings at 4.7 gigahertz all cores, the Maximus 11 formula is absolutely fine. The benchmark figures are just where you expect them to be. Frankly, there are no surprises, but then when you're running at auto settings, you'd expect that. This is a rock solid performer at 4.7 on all cores. Overclocked at 5 gigahertz, 4.9 gigahertz in AVX, it's a different story. The figures are all over the shop and frankly unpredictable, and I'm not quite clear what is going on. It's as though the board is just not performing particularly efficiently. It's taking in quite a lot of power, it's turning that into a lot of CPU heat, and the performance isn't there. It's like and I hate to use car analogies, it's like a car sitting there in the mud spinning its wheels and going nowhere fast. It's kind of like that. Sitting there at a rock solid 50 gigahertz in non-AVX workloads, 4.9 gigahertz in AVX workloads, and yet I'm not getting the results that I expect in all benchmarks. I don't really have an explanation for it. But here's the thing, when you're playing, say, games, doing something nice and straightforward, the difference between 4.7 gigahertz auto and 5 gigahertz overclocked in any CPU is just minimal, absolutely minimal, particularly when you're using higher resolutions where the graphics card is what it's all about rather than the processor. When it comes to workloads such as Blender, there is definitely a benefit to be gained when it comes to this particular motherboard, this Maximus 11 formula. On auto settings at 4.7 gigahertz, yup, I totally get it. 5 gigahertz? No, it's doing nothing for me whatsoever. What I'm seeing at the moment is a board that looks the part, it has loads of features for certain. The VRMs, I've got a question mark over the design and the layout in the first place, and then you get the really funky cooling system on top of the VRMs, but right now as things stand, the board just doesn't add up for me. Anyone who is even considering the idea of plumbing in those VRMs to a custom loop will of course require a custom loop. So I've ditched the 240mm all-in-one and I've added a custom loop to the CPU. We have an EK CPU block, 240mm Alphacool radiator, and an EK pump reservoir unit as a D5. And I've mounted it down that end so I can, in a moment, put the VRM cooler up this end. I still have the 120mm fan in the CPU area, but I want to give the VRM cooler a chance. The CPU is still overclocked to 5 gigahertz all cores, and changing from AIO to custom loop has made no difference to the temperatures whatsoever. If anything, it's actually made the temperatures 1 degree hotter because the fans on the radiator are spinning rather low and slow. It's fan speed that's going to make the difference to cooling this instance rather than the actual nature of the cooling. Custom loop or decent AIO for an i9-9900K, it's all the same thing. The next question, of course, is what happens when you switch to custom loop cooling on both CPU and VRMs? I'll be the first to admit this does not look pretty. However, you can see exactly what I've done. I've added a separate cooling loop for the VRMs. We've got a 120mm Alphacool radiator with a Phanteks Reservoir DDC pump setup, and it's plumbed obviously directly into the EK hybrid block on the motherboard. And the fact of the matter is, just as I expected, it makes almost no difference. It drops about 5 degrees C on VRM temps, which were already low and are now very low. In terms of effect, none. It just makes no difference to performance whatsoever. Clearly this is not the way you would plumb in a loop to your VRMs. You'd use a distro plate or you'd hook it into the CPU block or some such. You wouldn't have a separate loop for the VRMs the way I've done it. I've done this for convenience. It does, however, prove my original point, which is that the VRMs on this motherboard do not require liquid cooling. Let's get down to brass tacks. What do I think about the ROG Maximus 11mm motherboard? You're paying a lot of money. In return, you get a board that looks great, has a decent list of features, and it really doesn't overclock the least bit well. The accessory pack is fairly minor. I mentioned in the intro that you get a USB cable but didn't specify what it is. It's this thing here. It's got a USB 3 header at the one end and at the other end USB 2. So if you don't need both the internal USB 3 connections, you can add more USB 2. Neat idea, probably doesn't cost a lot of money. It's a very ROG kind of thing and I like that. So you're paying a load of money for a board that has an unusual take on VRMs. If you want a really sophisticated VRM, this isn't the board for you. There are other boards out there on the market that do far more in the way of power delivery, but obviously that's for the hardcore overclocker. Now that only makes any sense if you're using an i9-9900K rather than a 9700, for example. So you want all those cores pounding away at the maximum speed. You know, 4.9 is not enough for you. It needs to be 5 gigahertz or 5.1 or 5.2. With this board, the Crosschill EK3 cooler on the VRMs, I think you should just run it as it comes. Yes, it's got the G quarter unions. Ignore them. Forget about liquid cooling. You don't need it. I like the aesthetic of the cooler. The fact you can add liquid cooling, I really wouldn't bother. The armor, it's all part of the look of the board, of course. In terms of function, it's lots of plastic. I mean, you've also got a load of RGB. The RGB actually works very well. Thankfully, Asus has thought this through. So the M.2 cover down the bottom, you can access your M.2 SSDs even with the board populated. You don't have to rip the entire thing apart to get to a cover up here, for example. We've seen that with a few manufacturers. It's always a stunning faux pas. So the layout, the design is good. There are little bits and pieces you just don't need. You don't need the 4-pin EPS connector next to the 8-pin. You cannot feed enough power to this socket in any sensible cooling environment to make that necessary. It's for the look of the thing. You've got headers and connectors galore. The I/O panel is good, loaded with stuff. Don't quite understand the graphics output. It's not a problem. It takes up very little space. It's just slightly confusing to me. Headers and connectors around the board, well laid out. Excellent BIOS. The BIOS is really good. You can control everything on this board except for the fact that the overclocking really essentially does next to nothing. So out of the box, I would run my i9-9900K on auto, 4.7 gigahertz, all cores, XMP enabled, decent memory. Performance is good, no doubt about it, but the overclocking thing, not so much. And as a consequence, you're paying a load of money for a board that looks good and supports your processor well. You can get a board that functions as well for less money. Having said that, in this day and age, up to £400 for a motherboard is not extraordinary. Look at all the X570 boards. These days, 300 is mainstream, 200 is kind of budget-ish. We are in terrifying times. So nearly 400, 390 typically, 360 if you look around, is expensive, but it's not eye-wateringly expensive. So with that proviso, I'm gonna say, yes, it's a decent board, provided you're not fussed about overclocking. It is expensive, but it's not mind-blowingly expensive, and you do get some really solid hardware for your cash. If you like this video, give it a thumbs up, hit the bell button and subscribe. I'm Leo Warder for Kit Guru. This is the Asus ROG Maximus 11 Formula.